All right. Now the next thing that we're going to do is, we're going to set up the Cloud SQL. Okay. And as you know, Cloud SQL is what? It's nothing but the relational database plus vector DB combination. So if I just click Cloud SQL here, and if I click on Cloud SQL, now, yeah, you can see here this is a sandbox environment that it is showing us. Okay, now here it says experience Cloud SQL at no cost for 30 days. Okay, if you want, you can always read up on this. You can create it directly from here as well. Okay, but what we are going to do is we are going to build this from the terminal level. Okay, which means we're going to go and we're going to build it from here. Okay, meanwhile I'll just add the commands that we need in gcp commands.md. Now the time when you will be requiring you will be getting gcp commands.md, it will be very well documented, all of that. But as of now here, just for your understanding, I'm showing you the code, but when you actually will be working, you will be having a much documented and a cleaner version of this. Okay, so first and foremost, what we need to do is we need to create the instance. Okay, so in order to create the instance, I've already written the code here. I'll just kind of copy paste. Okay, so you can see Cloud SQL instances create. We're going to create this database called as clinical trial DB. Okay, and database version PostgreSQL. This is the tier that we're going to use, tier, sorry, which is dbf1 micro, region, and the name of the project. Okay, so let's build this. I'll just paste it here and I'll hit enter. Okay, would you like to enable and retry? I'll just say yes. Okay, so now it's saying enabling service SQL. You can see now it is showing us this. Okay, which means now it has started, you can see, creating the Cloud SQL instances. Okay, now this might take anywhere between 3 to 5 minutes. Okay, in order to create the SQL instance. Okay, now let it create the SQL instance for us. Okay, as of now, meanwhile, what we'll do is side by side, let us also focus on ingestion. Okay guys, now in ingestion folder, okay, right now if you see, we have roughly 4 files: clinical trials client.py, document parser.py, gcstore.py, and pubmed client.py. Just do one thing here, just create one more file called as runingestion.py. Okay, so runingestion.py is a file that you have to create separately. Okay, first and foremost, what we usually do is we're going to start with this file, that is clinical trials client.py. Okay, this is the file that we are going to start with, and runingestion.py is where we are going to basically build the, or rather trigger the entire pipeline. Okay, and if you look at clinical trials, this is basically entry point for all the data. Okay, so it shows failed. All right, so there's some internal error, it seems. Let us check what is going wrong. These things keep on happening, this is very normal. Okay, so it seems this is some GCP internal error. All right, so let me just run a command called as gcloud SQL instances list -- project, and the name of the project is clinical trials. So let me run this. All right, so it is showing us pending create, which is fair. Okay, so it is showing the primary address. Okay, all right. Now the instance was actually created is what I can see from here, but despite that there is an error. It shows pending create, which means the GCP is still provisioning it in the background. Okay, now let's do one thing. We need to wait for let's say 2 to 3 minutes, and then we'll just try to rerun the same command. Okay, all right, and after that we'll see that if our status is changing from pending create to runnable. Okay, and once we see this status being changed to runnable, we'll start working with it. It's totally fine. These things keep on happening. It's an internal error. Okay, which means it's an error from the GCP's end. Okay, coming back to clinical trials client.py, which is the first file. This is the entry point to all the data, okay, that you will be working with. All right, and everything that your pipeline is going to use, okay, depends on the study data, right? We're going to use the research data, okay, and if you actually look at this particular file, it is going to fetch, what is the purpose here? It is going to fetch all the clinical study records, okay, from the clinical trials gov, clinicaltrials.gov, the website. Okay, it is going to fetch all the clinical study records from there. Okay, and what it basically does, okay, first and foremost, it is going to connect to the clinicaltrials.gov, okay, or rather gov's public API. It is going to connect to public API, okay, and here we don't need any API key as such. Okay, then what it is going to do, it is going to search for the studies by condition. For example, the condition that you give is diabetes, cancer, anything, okay, by condition, intervention, or as per the sponsor. So there's always a research sponsor, right? Okay, after that, it is going to fetch the full study details, okay, for each result. What is this? When we actually dig into this code, we'll understand that much better. And it handles the pagination part, okay. Basically it returns some 100 results per page. If you can recall, we had set it to 100, right? And it is also going to handle the rate limiting, okay, and retries automatically, right? Cool. And we're going to use the async, which is concurrency, concurrency method here. All right. Okay. All right. This looks fine. Okay. Now let us go here back to the terminal and try to rerun this. Okay. All right. Still showing pending create, which is okay. So ideally this shouldn't happen though, but let's wait 2 more minutes. Okay, let's see. I mean, it's totally fine. As I said, things keep on happening. We'll do one thing now. We'll just keep on running this every 30 seconds or like roughly 45 seconds or so. Okay. All right. So now I'm just going to give you an idea, and then full blown we'll focus on ingestion. Okay. So as of now, clinical trials. The next is document parser. Okay. And what is document parser here now? Okay. It basically transforms your raw API response into clean structured internal schemas. Okay. So transforms raw API responses into structured, clean, internal responses. That is what this particular document parser is going to, or document parser PyDoc is going to do. Okay. You can imagine this to be a boundary between what API gave us, okay, and what my agent works internally. Okay. All right. And yeah, looks good. So now here, what this file is going to do? Okay, it is going to take the raw study, okay, or rather raw study dictionaries from the PubMed client. Okay, then it is only going to extract those fields which are required by the agent. Extract only those fields which are required by the agent. Okay, and then it is going to normalize the inconsistent data, okay, which is basically your missing fields, your null values, all of that, okay, dates. And then it is going to return us what? It is going to return us clean pedantic models, okay, which are ready for storage and agent use. So you can see each and every ingestion file is doing some or the other job. Okay. Still it is showing pending create. Okay, no issues, that's fine, keeps on happening. All right, okay, so this is about document parser.py. Okay, let's do one thing with our Cloud SQL. Okay, with our Cloud SQL, what we'll do is, let us just try to delete it. Okay, so I'll just put in this particular code: GSQL cloud instances delete clinical trial db project equals to mosaic trials. I'll hit enter. Okay, so I'll just delete this. So I'm going to delete the Cloud SQL instance. Okay, and then what I'm going to do is I'm going to recreate this with a different zone. Okay, that is what I'm going to do it. In the region itself, I'm going to create or use a different zone. That is what I intend to do, which means if I just go back to my GCP commands and if I see here, okay, I have the region, right? After the region, I'm also going to define zone. Okay, and I'm going to set it to, let's say, US Central 1F. Okay, this is what I'll intend to do. Okay, so this is deleting the Cloud SQL instance. Now let it do the job. Okay, let us go back and understand the next ingestion file, okay, which is the GCS store. Now from the name itself, you will understand what if you can recall, we had just created a GCS bucket, right? So what is this GCS store.py? It is basically going to save and load the documents to and from the Google Cloud Storage. Okay, that is it. Basically, it is going to interact with the Google Cloud Storage, the bucket that we created. Okay, and this is what, this is a permanent storage layer. Okay, for a permanent storage layer for what? For all the raw and parsed docs. Okay, what it does, it basically saves the raw API responses to JSON. Okay, raw API responses, okay, to GCS bucket as JSON. Okay, then it is going to save the parsed study and paper records, basically the research paper records, to GCS again as JSON. Okay, then what it is going to do, it is going to load the documents back, okay, from GCS, okay, when the agents need them. Okay, and it is going lists and it is going to list down all the available documents by prefix. Okay, which is useful for batch processing. As of now, I'm just giving you a very high level idea what it is going to do. Okay, so that you are in tuned with what are happening. Okay, I can understand for some, it might be, hey, what are all these things happening, but try to understand we are building multiple things together. Okay, all right, now here the question you might have is why we save the raw data first. Why are we doing this? Okay, the simple reason can be, let's say if my parser has a bug. Okay, even if my parser has a bug, the raw originals are safe in my GCS. Okay, in my GCS bucket, right? So we can reparse them at any time without refetching from the API, right? And this is called as the raw zone or the processed zone. Okay, or raw zone process zone pattern that is typically used in data engineering. In fact, there is the project that you use, you're also going to see some hints of data engineering here. Okay, and typically how can you expect, or what kind of folder structure can you expect in the GCS bucket? Okay, you can just say raw, then in raw you'll find studies. In that you will find some some document and then .json. Okay, and this is the document, like exactly what this is going to be, exactly what the API returned. Okay, then you will be having raw papers, then again some number .json. Okay, let's say this is exactly what PubMed returned. you're going to work with two sources, right? clinicaltrials.gov API and PubMed. Okay, let's say you got these two. You from clinical trials you're going to get studies, from PubMed you're going to get research papers, both of them in JSON. Okay, then you're going to parse it. That parse will go in the processed folder. Let's say I'm going to have this followed by this, and then you will see that in parsed here. Sorry, not this one. Sorry, what went wrong? Something went wrong. Yeah, this one you're going to see it here. Okay, and what is this? This is basically your parsed study as JSON. Okay, and then again you will find processed papers followed by this one. Okay, and this one you're going to find as what? This is basically your parsed paper as JSON. Okay, so we're going to maintain two things in our Google Cloud storage. One is the raw data and other is the parsed data. Okay, so that is what we will be using. Okay, all right, so coming back, you can see the GCS, the clouds instance. Okay, the deleting has been done. Okay, so you can see deleted, all of that. Okay, now let me do one thing. Let me just paste the new code. If you see here in this code, I'm defining the zone as well. Let's see if this is working for us or not. Okay, okay, for detailed information. Okay, something went wrong. Okay, let me just check it once again. Okay, what is going wrong here? Okay, it is saying that at one of them, okay, can be activated. Okay. All right, so let's do one thing. We'll remove the region and use zone only. Okay, so let me paste the new code here, and in new code what I'm going to do, I'm going to remove the region. Okay, the region tag, and if you see in region tag, I'm only going to use the zone tag. I'm going to hit enter, and let's hope the SQL instance will be created now. Okay. All right, now let's go to the next part. So I'm just going to mention all these codes in our GCP commands.md. Okay, and if not, you can always watch this session and you can try to type the same codes in the in the terminal. Okay, because now you're learning AI engineering. This is the basic that you should at least know as to how to write commands in bash terminal. Yeah. All right, next is PubMed client. Okay, and what is PubMed client? Okay, this is it is going to fetch the research papers, okay, from the PubMed website. Okay, that will reference to a specific clinical trial ID. Okay, so as per the clinical trial ID, it is going to fetch that research paper for us. Okay, and this is basically our second data source. Okay, this is our second data store. Okay, what it does basically, okay, first and foremost, it takes something called as an NCT ID. NCT ID is basically a unique identifier for your research. Let's say NCT, this is the unique ID for that matter. Okay, now basis this NCT ID, it is going to search the PubMed. Okay, it is going to search the PubMed for papers that reference that particular trial. Okay, for example, as I said, the research trials are currently going on with understanding a protein powder that claims that in one scoop we give 40 grams of protein. Okay, so and the trials are going now for we are going to reference that trial, and we're going to say we're going to extract the research paper for that. Okay, then it will basically fetch the full abstract, okay, and the metadata for each paper. Now if you can recall, research papers have abstract, right, and they also have the associated metadata. So we're going to fetch that. Along with that, it returns the raw paper records. Try to understand, no cleaning happens here. No cleaning happens here. Okay. All right. Now, why do we need this? You might ask, hey Chirantan, we are already using clinicaltrials.gov API. Why do I even need PubMed in the first place? See, try to understand. Clinicaltrials.gov tells us what a study promised to measure. Okay, so clinicaltrials.gov tells us what study, okay, was promised to measure. Okay, and PubMed tells us what research actually published. PubMed tells us what researchers, okay, what researchers actually published. Okay, try to understand this, which means, let's say I am going to say that my paper is going to, my research is going to do this, but at the time of publishing that research, what did I actually publish? Okay, did I say that I'm going to innovate 10 different things and I innovated only 6? So what about the 4? Okay, so, and the gap between two things, or those two things, which means what the study claimed to measure versus what the research was published, is where the signals live. Okay, this is where we're going to get the signals. It's basically the difference between the two. Okay, and then finally we have the run ingestion.py file. Okay, run ingestion.py file is nothing but it is going to run the entire ingestion pipeline. Whatever you have to run in ingestion is going to trigger all of this from here. Okay, so you're basically going to run this file, okay, to fetch studies. Okay, you're going to fetch papers from here, you're going to parse everything. Okay, and then you're going to save it where? You're going to save it to the Google Cloud storage. Okay, so what it does typically, it is going to fetch the studies from clinical trials. Okay, fetch the studies from clinicaltrials.gov. Okay, then it is going to save the raw study data to the Google Cloud bucket, GCS bucket. Okay, then it is going to parse the raw studies into clean structured records, typically JSON. Okay, then it is going to save those parsed records, okay, or parsed studies, whatever you like to call it, to GCS. So now you have two folders, right? Raw and processed. Okay, and then for each study, okay, for each research study, it is also going to fetch the related research papers, okay, and then it saves raw and parsed both the papers to the GCS. Okay, so these are all the things that your ingestion, your ingestion typically has 4 different parts. If you look closely, clinical trials, document parser, GCS, and PubMed. Run ingestion is going to take all the files together and it is going to basically run the entire ingestion pipeline. Okay, that is what it intends to do. So that was, guys, basic understanding of ingestion. Now let's, in the next video, we'll see if the Cloud SQL instance is being created or not.